Today we are working with triangles, and we're going to look at all types of triangles. So there are two ways we can classify triangles. We can classify them by their angles, or we can classify them by their side lengths. Let's start with our angles. If we're going to classify triangles by angles, we can use acute, right, or obtuse. Now, an acute triangle simply means that all three angles have to be acute angles, and acute angles measure from 1 degree to 89 degrees. If we're looking at a right triangle, only one of the angles is going to be a 90-degree or right angle. The other two angles have to be acute angles. An obtuse triangle means one of the angles has to be an obtuse angle, which is 91 degrees to 179 degrees. Then the other two have to be acute angles. So those are ways that we can classify triangles by their angles. If we're looking at their side lengths, we use completely different terminology. So if we're looking at side lengths, we could have an equilateral triangle, which simply means all three side lengths have to be the same measure. We can have an isosceles triangle, which means two of the side lengths have to be the same measure. One side length has to be different. Or we can have a scalene triangle, which means none of the side lengths are the same. So if we go and we want to solve some problems with triangles, the first kind of problem they're going to ask us is to find a missing angle. Well, we know by definition of a triangle that when we add all three angles together, they have to equal 180 degrees. So if they give me two out of the angles, I can set up an equation to find the third angle. Now, when I set up my equation, I put all of my angles on one side of the equal sign, and I put 180 degrees on the other. So I don't know what A is, so I'm just going to say it's A. But I know my second angle is 52 degrees, and my third angle is 48 degrees. Now, I can gather my like terms, so pull 52 and 48 together, and I get 100 degrees. Now I have a simple one-step equation to solve. So if I have A plus 100 equals 180, I'm going to subtract 100 from both sides to keep it balanced. I see A equals 80 degrees. So that's an easy one to solve. Now sometimes they're going to ask us to find side length. Well, if they're going to ask us to find a side length, they have to give us a perimeter. And that perimeter is going to be one side of the equal sign, and the three side lengths are going to be the other side of the equal sign. So I have two side lengths that I'm going to call X, and then I have one side length that is 4 inches shorter than the other two side lengths. So I'm going to call that X minus 4. Well, I can go and gather my like terms. That means I'm going to gather all my X's together because they're the same thing, and I'm going to make that 3X minus 4. Now I have a two-step equation. I can add 4 to both sides, and I'm going to get 39 equals 3x. Then to get x by itself, I'm going to divide by 3 on both sides, so I can see x equals 13. Now I still need to identify what my side lengths are. So I know that side length 1 is 13 minus 4. That means that's got to be 9 inches. Side length 2 and 3 are x. So they both have to be 13 inches. So that's how we do it with a perimeter in finding a side length. So our final one, which always seems tricky, is what if they give us a ratio? What if they say, find the angle measures given the ratio that 1 is 7, 1 is 9, and 1 is 20. Now, it doesn't mean that they measure 7, 9, and 20. It means that the ratio is 7 compared to 9 compared to 20. I don't know what that angle measure is. So what I do is I set up an equation, and again, all my angles have to go on one side. So I'm going to say 7x, because I don't know what the degree measure is, plus 9x plus 20x. So I'm just taking my ratio numbers. And I know if they are angle measures, they have to equal 180 degrees. So now I'm going to gather my like terms. So 7x plus 9x plus 20x is 36x equals 180 degrees. Now it's a one-step equation. I'm going to divide both sides by 36. I get x equals 5 degrees. Now that doesn't tell me my angles yet. I got to go back and plug that back into the ratio. So I know 7 times 5 would be 35 degrees. 9 times 5 is 45 degrees, and 20 times 5 is 100 degrees. And if you add up all those three measures, they do equal 180 degrees, which means we have our triangle. So those are all the different ways that we can solve for either angle measurements or side length measurements with triangles. I hope you have fun with this. Good luck.